Guys, so I'm going to partially speedrun this because... Partially speedrun it, okay? Because there's a lot of stuff in here which I could waste time teaching you right this second, but you have already been taught it, okay? So, partial fractions with binomial expansion. If it says express f of x in partial fractions and hence obtain an expansion of f of x in ascending powers up to x cubed, a state range of values of x, well, obviously do what it tells you to do. Find partial fraction and then expand it, okay? I'm not going to go through the steps to do the partial fraction because we've spent a couple of lessons already doing that. So you'd go through your normal processes of doing f of x, your a over 1 minus 2x and your plus b over 1 plus x, blah de blah de blah. You'd do all that, okay? It's on page 179, I think. No, it's on page, 179. So you'd go through that entire process, okay? And you would end up with a situation where you get 10x plus 1 over 1 minus 2x. 1 plus x is equivalent to a, which would have been 4 when you've worked it out, over 1 minus 2x, plus your b, which was actually minus 3. So minus 3 over 1 plus x. Okay, so that would be your partial fraction. I'm not doing the partial fraction, but that would be your partial fraction if you did it. Okay. Once we get to this point, it's now about thinking about how we can write this so we can expand it. So identifying the fact that each one of those can be rewritten as a negative 1 power. So this is 4 times 1 minus 2x to power minus 1. And this is minus 3 times 1 plus x to power minus 1. Okay? We want the terms which go up to, I think it said x cubed. Yep, x cubed. So, because both multiplications, the 4 and the 3, neither of them have an x term, we're going to do both of these up to the x cubed bit. But basically, at this point, rather than trying to deal with it as one long string, my best advice is to just write out what is 4, 1 minus 2x to minus 1 as its expansion, and what is negative 3 times 1 plus x to the minus 1 as an expansion. Okay, I know I've put the minus 1 in the wrong place there, and that was a massive rubber. Okay, so do them separately and then recombine, because it's just going to get messy on your page otherwise. So, the expansion of 4, 1 minus 2x, we don't need to take anything out in that case. Both of these, I think, are 1 pluses. Yeah, are 1 minus. Which means that there's nothing really difficult to deal with. So, well, in fact, they've even got rid of a 4 here, but I'm going to keep the 4 in. So you got 4 times our 1 plus n, which is minus 1, times our x, which is minus 2x, plus our n minus 1 over 2 factorial, times our x, which is minus 2x squared, plus our n minus 1, n minus 2 over 3 factorial, times our x term, which is minus 2x, I'm getting messy again, cubed, okay, so on and so forth, okay. The other one, minus 3 times 1 plus minus 1 x plus minus 1 minus 1 minus 1 over 2 factorial x squared. There's a lot of just like following procedure here. It's just memory more than anything. Not really much thought process going into any of this. It's just, can I remember the expansion and how it looks? Okay. So yeah, we got both of those. Don't think I've made any mistakes. If I have, I apologise. Oh yeah, I put a squared there. Should be a cubed. And then simplify each one of these down. Oh, hello. I'm just giving myself some space. So what does that become? Well, it's 4 times all of this. So 4 minus 1 times minus 2x is positive 2x times 4 is plus 8x. Minus 1 minus 2 is positive 2 over 2 factorial is 1. Minus 2x squared is positive 4x squared times by 4 is 16x squared. Yep. Okay. And then the last one, minus 1, minus 2, minus 3. In reality, if you got minus 1 over the 3 factorial, you can just think of it as, well, in this case, it would be negative 3 factorial over 3 factorial, which is just negative 1. Does that make sense? Well, minus 1, minus 2 is basically like the negative 2 factorial. Because it's factorial means ascending numbers, sorry. No? 1 times 2? 2 factorial is just 1 times 2. On top you've got minus 1 times minus 2. They're cancelling each other out. Yeah, it's just the sign that's remaining. So that would have been positive 1, whereas this is going to be negative 1. But you can just use a calculator. Maybe it's worth just sticking to the calculator after that. Minus 2x cubed is negative x cubed. So I've got negative 1 times negative 8x cubed, which is positive 8x cubed, times by 4 is 32x cubed. Okay. When is that valid? So that is valid for when modulus minus 2x, which is pretty much the same as modulus x, is less than 1. Okay. They've written this as an inequality now. Okay. So they've rewritten this as x is less than a half greater than negative a half, because that's the only things which will satisfy that situation. Yeah.
How do we get like the valid number from?
What, the final valid?
Yeah.
That's what, as in like at the end, what the final valid is.
No, like for here you said modulus x is less than 1.
That's modulus minus 2x is less than 1.
Oh yeah.
Because you take the modulus of the x is less than 1. It's always, that's just the rule.
No, like where did you get the 2?
It's in front of 2x.
Okay.
Yep. Is that right?
How did you make it a range? Like from that?
So I just divided through. So if modulus minus 2x is less than 1, you can say minus 2x is less than 1 but greater than negative 1. Because that was moduluses as part of chapter 1 that we looked at. And then you just divide both sides by negative 2, which gives you, well, the 1 would become negative a half. So that 1 would become negative half, and the negative 1 would become positive a half. Kind of just swaps them around. It doesn't really matter. The negative, remember, swaps your signs over. So if I was really doing this in full, I would say that actually this becomes 1 less than 2x less than negative 1, which becomes half less than x less than 1. But you wouldn't write it that way round, you'd write it the correct way round. Does that make sense? Yeah, cool. All right. So that's how we got that. Everyone okay with the modulus minus 2x less than 1? Yeah, cool. And then just dividing both sides by 2, basically. The negative has no impact in reality. Okay. Looking at the second one, that's going to give us, I'm just going to read out the answer and you can work it out later on. 3 minus x plus 3x squared, sorry, negative 3, positive 3, positive, oh, damn it. This is why you don't skip, sorry, minus 3 plus 3x, negative 3x squared, plus 3x cubed. Okay? Any questions about that? Okay. Right, and then this is valid for when modulus x is less than 1 because there's nothing in front of my x here. So that is x is less than 1, x is greater than 1 as a range. Negative 1, thank you, sorry. Okay, so I've got these two. Now it's just about combining it. So I've got my, what's in between it? Well, it was a minus, but I've already done the minus expansion, so I don't need to worry about that negative expansion. Now I can just add this value to this value. So I would just do this as 4 plus minus 3. Oh, crap. So 4 plus the negative 3. I've got plus 8x plus 3x. But I've already done the minus for it when I did the expansion here. Yeah, you could have done it as just 3 times and then taken away. You could have done it how they've done it, which is they've expanded it just without the multiplied through, and then put the multiplied through back in at the end. It's just about your handling of numerical values, really. So plus 16x squared plus minus 3x squared plus 32x cubed plus 3x cubed. I'm just writing it like this just because I like to collect my terms as I go along, as opposed to writing them as two separate ones and then bouncing around the equation. So 4 plus minus 3 is 1. 8x plus 3x is 11x. 16x squared minus 3x squared is positive 13x squared. And then the last one is plus 35x cubed. Infinitum. Okay. The last thing is to identify what is our range. Okay. Because one of our ranges, we had this, minus 1, x is less than 1, but greater than negative 1. And our other range is a half and a negative a half. Okay. So, does anyone know what you need to do? What's our final range?
Number line.
In the book, they've done a number line to try and illustrate it. Basically, you have to make sure you are satisfying both inequalities. Okay? Yeah, so it's just going to end up being the top one, because the top range is within the bottom range. Okay? But you can't have the extra bits. You can't have like a 3/4 because it does not satisfy our top range. Okay? So the way they demonstrated this in the book was they were like, oh, here's a number line. You know, our inequality for the bottom one is minus 1 to 1. Our other one is from minus a half to a half. Okay? We need to satisfy both of these, so the only way to satisfy both is to just be within that region there. So our final inequality is that x is less than a half, but greater than a negative a half. Okay? I don't know if I've seen any questions like it, but, you know, just in case it ever does come up, if you have two inequalities which overlap like that, your range would be between there and there. Okay, it's the overlap. Okay, of the inequalities. Cool? I don't think that can actually happen with these. Maybe it can. I've not done these in ages.
So how many marks would you get
For one of these questions, I would expect a lot.
11?
Oh, probably not 11, maybe 8.
Only 8.
Maybe 8.
You get 1 point on this.
Yeah.
Nah, like, there's ever carried forward marks a lot.